Suppose we are trying to solve the integral of this format, integral of x square cosine of x dx. So we know in order to solve integrals of this type, we need to apply integration by parts, which if I apply in this case, we will have to choose the function or the order of the functions using the Euler rule. The Euler rule, which signifies that trigonometric functions shall be taken afterwards of algebraic functions. So x square will be taken as the first function and cos x will be taken as the second function. So here if we integrate it by parts, what we will end up getting is x square integration of cos x dx minus integral of, we have to take differential of this function which is 2x times again integral of cosine of x dx. So if I simplify it, we know integral of cos x is nothing but sin x, ddx of sin x is cos x, so integral of cos x will be sin x minus 2x, again there will be a sin x dx. So as you can see, after the first by parts, what we are left with x squared sin x minus integration of 2x sin x dx. So we again need to apply integration by parts on this one. So if I do that, what we will be getting is, I take 2 common and it's integration of x sin x dx. So again we need to evaluate this x square sin x minus 2. I take x as my first function, so integration of sin x dx minus integration of, taking derivative of x is 1. So we need to keep on simplifying this. Now integration of sin x is minus cosine x. So still I need to do this integration. This process is lengthy, as you can see. This will be minus minus, it will become plus. Minus will come out and it's integration of cosine x dx. We all know that ddx of sin x is cosine of x. This process is really lengthy. This process is really lengthy. So this is the final answer which we have obtained. Now I am going to demonstrate an easier method of doing this entire problem. So this was the integral which we had, and in order to do this integration quickly, I am going to demonstrate a shortcut technique. So this x square, the first function, this x square I am going to write here, and this second function I am going to write over here. Now simply we are going to take derivative of this first function. The derivative of x square is nothing but 2x, the derivative of 2x is nothing but 2, and the derivative of 2 is 0. So similarly I have taken derivative of this, and now I am going to take integrals of this function. Now integrating cos x will give me sin x. So ddx of sin x is cos x, so integral of sin x is, integral of cosine x is sin x. Now if I take integral of sin x, I will get minus cos x, and integral of minus cos x will give me minus of sin x. So now I am going to draw arrows like this. I am going to take the derivative until I get 0, and thus in order to level up, I am going to take the integral in the similar range. If I wanted, I could take more integrals, but as I have got a 0 on this side, so I will not take further integrals. So this is just a shortcut technique. So the rules do not have any proof. Plus minus plus, so this will come accordingly, and now I have to multiply x square with sin x, and I have to multiply 2x with cosine x following this negative sign. Negative and negative will become positive, so 2x cos x, and here negative and positive will be negative. So you can see that these two answers are completely same if I put a constant over here. So this was the shortcut technique. Thank you.